Quite often I need a power supply to connect or test something, but to get the required voltage, I usually have to quickly throw something together from whatever I have on hand. Usually it's just inconvenient, and sometimes it's simply not possible. So today, I'll show you how to turn an old computer power supply into a lab bench power supply with fine output voltage adjustment. I happen to have a power supply lying around from my very first computer, which means it's already over 20 years old. First, I disassembled the power supply, disconnected the fan, and cleaned out all the dust. Then I unscrewed the board and cut the wires connected to the 220-volt input so I could remove the board from the case. I also removed the power socket, the power switch, and the cooling fan. Next, I cut off everything unnecessary and sorted the wires by color. Each color corresponds to a specific voltage. If you have a more modern power supply where all the wires are the same color, you can use the connector as a reference. I decided to keep the original case, so I painted it black. Now that everything is painted and cleaned from 20 years of dust, it's time to put it all back together. Thanks to the original case, we keep proper grounding and the original layout, which is a big plus. Of course, the original PSU case alone isn't enough, so I designed 3 additional parts for it. The advantage is that PC power supplies follow the ATX standard, which means they're all the same. So this project is easy to replicate. If you need the 3D models, leave a comment. I'll drop a download link. The first part is a frame for the original power supply. I printed it and installed threaded metal inserts for screws. The idea was to fit the PSU into this frame, and it worked perfectly. The second part is also 3D printed. It serves as a case for the custom part of the power supply. And the third part is the front panel, where all the controls and connectors will be installed. As for the additional components, they're very cheap. I'll go into more detail next. Before assembling everything, I cut off unnecessary wires and shortened the ones I needed. Then, I combined the power wires in groups of 3 to handle higher loads, tinned their ends, added connectors where needed, and insulated everything with heat shrink tubing. Now we can move on to the assembly. First, I installed an XT60 connector. It will have adjustable voltage and is useful for some of my devices. The second component is a 120-watt voltage regulator that allows adjusting the output voltage from 0 to 36 volts. It's inexpensive, but it has an LCD display, active cooling, and overall decent build quality. Below it, I installed 2 banana sockets. They will also provide adjustable voltage, just like the XT60. I also added 1 ground socket and 3 sockets for 12, 5, and 3 volts from the original PSU rails. Now it's time to connect everything. First, I connect the 12 volts from the PSU to the positive input of the voltage regulator. Then, I connect the PSU ground to the negative input of the regulator. To connect the XT60 and banana sockets, I made 2 splitters from the PSU wires and connected them to the regulator output. One end of each splitter goes to a banana socket and the other to the XT60 connector. The main thing here is not to mess up the polarity. At this point, I could already stop, since this is basically the core of the power supply. But since there was extra space on the front panel, I decided to add a USB port with fast charging. It accepts 10 to 30 volts input, so I connected it to the 12-volt line, making sure the polarity is correct, and mounted it in place. Next, I connected the PSU ground to the negative output on the front panel and moved on to the power switch. The green wire is responsible for turning on the PSU. I soldered it to one terminal of the switch and connected ground, black wire, to the other terminal. For the power indicator, I used a red LED, soldered a 1K ohm resistor to it to prevent overheating, and connected it to the 3-volt line. I insulated the LED legs with heat shrink and mounted it in place. It fits tightly, so it won't fall out. Now all that's left is to connect the 3, 5, and 12-volt outputs directly from the PSU. And finally, I installed the front panel and screwed it into the threaded inserts. After that, my lab power supply is ready. To test the voltage regulator, I used an LED. It clearly shows how the voltage changes. The regulator itself has various settings that I haven't explored yet, as well as current and power readings for the connected device. I also checked every output on the panel. No surprises, everything works exactly as intended. Now working with electronics has become much more convenient. Thanks for watching.